Alright, so after the footing design, we now are ready to analyze our structure. Go to Analyze menu, then click Run Analysis. Then choose Staad Analysis, then click Run Analysis. Okay, so it will take just a few seconds. Then after that, you can choose what to do afterwards. So if you choose, you have the option to choose View option or Output file. Go to Post-Processing mode or stay in the modeling mode, meaning you have to stay back here, modeling. In our case, we'll go to the Post-Processing mode first, then click Done. So the Post-Processing mode is here. If you'll notice, we have a different window here and we have a different set of tabs here. Okay, so because these are now in relation to the results of our analysis. So we have here the Node tab, the Beam tab, the Animation tab, and the Reports tab. Okay, so we'll go first to the Nodes tab. So the Nodes tab, we have two options: Displacement Results and Reactions Results. So for Displacement Results, we have here at this window the displacement values of each of the node. Okay, node 1, node 2, node 3, node 4 until node 18. So for you to know which node is number 1 and 2 and so on, you have to label your model with node numbers. So right click in the screen, then click Labels, then click Node Numbers, then Apply, then OK. So we all know that if you select this one, click, that's node number 1. Okay, 1. This one is 2, 2, and these are all the results, displacement results for each node. Okay, so for node number 1, we have 3 load cases. So live load, dead load, and the combination load. Then for this column, we have the horizontal X, or the X displacement along X. We have displacement along Y, displacement along Z for live load. This one is displacement along X, Y, and Z for dead load, and displacement X, Y, and Z for the combination load. That's for load 1 alone. For load 2, the same. For live load, for dead load, and for combination load, and so on until node 18. Alright, next is the reactions at the support. Click Reactions at the support. So we have here the values of the reactions at the support. Okay, and these are all the results for the reactions at the support. So we have node 7, we have for the reaction due to live load, reaction due to dead load, and combination load. For node 8, this one, reaction due to live load, reaction due to dead load, and reaction due to combination load. Of course, there is also moment here, moment due to combination, moment due to dead load, and moment due to live load. So you can see here the results, the reactions of node 7. This is node 7. Node 7, this one. And that's the live load. You see, 4.052, 4.052 along X. That is because it is selected here. So if you select dead load, then the values here are reflecting the reactions due to dead load. This one is the reactions due to the combination load of 1.4 dead load plus 1.7 live load. Okay, so that's it for the nodes results. Alright, next will be the beam tab, beam results tab here. So we have three options here: forces, beam stresses, and beam graphs. So you have here beam forces. Okay, so this is the graph of the beam forces. But first, let us label the model with beam numbers. Right click, then labels, then select beam numbers, apply. Then we have beam numbers is located at the middle of the member. So for example, this one, this is the beam number, and the beam has two endpoints, so we have node number 1 and node number 2 for this beam. So for the beam forces here, we have beam number 1, beam number 2, beam number 3, and so on. So for beam number 1, we have, for the live load case, for beam end, for node 1, this one, node 1, for beam 1, these are the beam forces: Fx, Fy, Fz, Mx, My, and Mz. F for the forces, M for the moments. For the other end, node 2, this one, this is node 2. For beam 1, these are the results of beam forces and moments. That's for the live load alone. For dead load, again, it will repeat based on the dead loads. And for the combination load, again, these are the beam forces for this end and this one for this end. Okay, until the last beam, beam 26, this one, or the column. Okay, so same with the stresses. Click here, and these are the stresses of each beam tabulated here. So this is beam 1, beam 2. These are the combination load, live load, dead load, and combination load for beam 1. Then we have the graph. Click the graph. This is the moment shear moment diagram. This is the shear or the moment diagram. This is the shear diagram. Okay, so for example, this beam 1, if you select that one, this is the moment and the shear diagram of beam 1 on this load case. Okay, load case. If you want the load case dead load, then this is the moment shear and moment diagram of this beam on this load case. So when we design, you usually look for the highest value. So usually you can check, but usually it's the combination load. So in the combination load for beam 1, the maximum moment at the ends of the beam is 49.3 kilonewton per meter, and at the mid span here is 33.5 kilonewton per meter. For the shear, since we will be computing for stirrups, you need the shear value at the end beam, so the maximum shear value is 66.2 kilonewton. Okay, so example for this beam, so you're designing moment. If you design your beam in other software, for example in a spreadsheet, you're designing moment at the end of end beam. For this beam, for this beam is 43 at the end, and the midspan is 29.1. Shear value maximum is 57.7. Also is for the column. We have here, please note that this is the node 6, this is also node 6, this is node 8, this is also node 8. Okay, this is beam 9, node 6, node 8. Beam 9, node 6, node 8. So these are the results for this beam or column. You have 20 at node 6 moment at node 6, 20 at the other end, it's 9.82 kilonewton per meter. The shear at here is 9.94, at the other side it's also 9.94. The axial load for this column is 206 at node 6 kilonewton, and at the bottom is 215. That is because the load of this column, or the dead self-weight of this column, is already added at this node. Alright, so that is the moment shear axial force diagram for each member here. So if you choose this member, you have here the corresponding diagrams. But if you want to look at the moment diagram for the whole structure shown in this model, you can do so. But first, let us hide the loadings. We'll just hide this one because it looks messy if you have the loadings here, and also with the together with the moment diagrams or shear diagrams, so it's kind of messy. So we will remove that one, or hide that one only, not remove, hide. Okay, so right click, go to labels, then go to loads and results tab, then uncheck this one, loads direct, then click apply. So the loads, the live load, dead load, and the combination loads are hidden out of sight, but it's not deleted. Okay, so if you want to look at the moment diagram, you go back to beam, then forces. Actually, this is already the moment diagram. So if you want to exaggerate the diagram, you can go change the scaling of the diagram. So you just right click, go to labels, go to scales, then since it's a moment, so we will change the bending, result of the bending. This is the scaling. So 100 kilonewton per meter is the scaling. So if you wanna exaggerate it more, like that, so change the value of the result scale. This is just the scale of the shear diagram in the drawing, or the bending diagram in the drawing. If you're satisfied with that, click OK. Alright, now if you want to have the values of the moments on the members, you can click results, then click view value, then you can click beam, then since this is bending, so we will check somewhere here. If you want the bending moment values at the ends, check this one, or only, or that, or if you will include the maximum bending moment, check this one. And if you want also the midpoint values, midpoint bending moments, check this one. In our case, let's just check the maximum bending moments for each member. Okay, so check that one, then annotate, click annotate. So you have there, press close, you have there, let's make the screen bigger, you have there the maximum moments for each member. So for this member, we have the maximum moment of 17.1. Let's check in the beam graph if that's 17.1. So check, we have here 17.1. For the for this beam we have for this beam, for example, beam 1, 49.3. Let's check at the beam forces. So this one will should have the same value. So you have there 49.3, 49.3. Okay, so if you want to show instead of the shear moment diagram, you want to show the shear diagram, go back to labels, right click, labels, then go to loads and results tab and check this one. So instead of bending, you want the shear diagram in the model, then apply. If it looks very thin, you can check or change the scale and go to the shear values to increase the drawing, not too much, like that. Then apply. If you want to view the values of the shear forces, then go to results, view value, then beam results. Then for the shear options, if you want the maximum only, click maximum. If you want the ends only, check the ends, or you can do both or all. So let's just say the ends, the shear at the ends. We want to know the shear at the ends, or we want to show the shear at the ends in the model. Okay, annotate. So those are the values of the shear at the end points of each member. Okay. Now let's go to the animation. Okay, the animation tab lets you visualize the behavior of the structure when that certain load case is imposed. So let's check the animation tab. Click animation tab. So you have there no animation, diagram type, deflection. You want to animate the deflection or the section displacement. In our case, we will check deflection. We'll try to see how the structure will deflect on certain load cases. Okay, so deflection. And since deflections are very small, has a very small value, we have to exaggerate it. Okay, we have to exaggerate the scale, just like we exaggerate the moment diagrams or the shear diagrams. We'll also scale or exaggerate the scale of the deflection. Okay, so to exaggerate the scale, go to Scales tab. Then for the displacement, this one, so we'll lower the value. So you'll notice there's a certain movement now. If you go lower, so you will see how it behaves. So I think that's it. That's very clear, and how you can clearly see how the structure behave when the combination load is applied here. Okay, so if you choose the dead load, deflection might be a little bit much smaller compared to the combination load. So for the live load, that is the animation for the deflection of the structure. Okay, so you will know, based on visual inspection, you will know which member has the largest deflection and so on. This is also very good if you want to visualize the movement of the structure when seismic loads or lateral loads are applied. Okay, so much for animation. Let's go to reports. Of course, when you perform Staad design and analysis, you need to print or to save reports. So this is where you create your reports. Okay, let's click reports. and we have here some tabs. Okay, so items, load cases, modes, ranges, still design, load, save, logo of your company, other options, pictures or albums if you have. Okay, we'll go back to items tab. So if you'll notice in the available drop down menu, you have input, meaning those items you input. Okay, so what are your input data? Of course, the coordinates of your model, the properties of your model, the loadings of your model. Those we have all of those we have done in the modeling mode is here in the input. So properties of the structure, load combination, design, and so on. Then the output is those data after Staad analyzes your input. Okay, so let's check first input. These are the choices in the input. So if you want to report the nodes of your structure, the beams of your structure, you just transfer it to the other side. So notice that there's already job info here. The one that is optional, the one with the job name, reference, client number, designing engineer, dates, approves, check. This is already here selected. So if you wanna disregard one, you can transfer it to the other side. So you have no report here, meaning your report is still blank. So if you want to have nodes, beams in your reports, section, materials used, supports, releases, primary load cases, you can transfer it to the other side. So in our case, let's just go for one report here in the input. Let's say primary two load reports, the primary load case and the load combination case. So that will be part of your report. Only 2 for the input data. For the output data or the result of your analysis, these are the choices: no displacements, displacement summary, beam displacement detail, and so on. So let's just choose one just to show you how to make a report. So beam end, let's say beam end for summary, beam maximum moments. What else? Reactions or reaction summary. So you have 3. Okay, reaction summary first. Then we have, let's say, beam maximum moments and beam shear force, maximum shear forces. That's it. Then next is pictures. Actually, you can take pictures of your model or anything you want here in Staad. So if you want to take pictures with the loading, you can take pictures of it. If you want to take pictures of the model with the shear diagram, you can take pictures of it, but I will not discuss that one. Okay, reports, there's none. For the pictures, of course, there's none because we did not take pictures. For this one, this is another software, and for still design, there is another option for the still design output, but we are not using still design, so that's it. So in our report, that will include the reports for primary load case, which is the live load and the dead load. For the combination load, that's the report for the combination load number 3, 1/4 DL plus 1/4 or 1.7 LL. For the output of the Staad or Staad output results, we have reaction summary, beam maximum moments, and beam maximum shear forces. So that will be a report that will contain, or that will be all for our report. Okay, so you press OK. Now if you want to import your report in Word file or text file, go to File, then, export report, go to File, then Export Report, then go to MS Word file. our Microsoft Word file, then tutorial 2015.doc. You can save that one in any folder you want. Click OK, then wait for a while. Just wait for a while. If it's not working, then retry. Okay, after retrying, there's a template for the report. If you install Staad Pro, there's a default template. Check that one, Staad Pro, then click open. That will be the template of the report. Okay, then if you have Microsoft Word, it will open together with the report. So the report is still being made as of the moment. Okay, so the more data you will include in your report, the larger is the Word file and also the number of pages. Okay, some items here are not accommodated by our paper. We can adjust that one using our Microsoft Word skills, because these are all tables, so you can adjust the table so that it will fit the paper size. So let's go back. This is how the report is done. It's still writing as of the moment. Then after that one, you can save that one. Okay, you save that one. So let's go back now to our Staad application. Alright, so we have discussed the basics on the Staad post-processing mode. This is the post-processing mode. If you look at this, here it is, mode. Sorry, it's not yet working because it's still occupying the data on the Word file. We will just close this one. If you want to save the file, you have to wait. But in our case, that's it. It's done. Okay, so if you want to adjust the tables, just click there. Let's say this one. No. Okay, this one. Then adjust this one. Something like that to fit the table. Okay, for this one, you look for that certain for a while. View one page, then highlight, then look for this point, then drag it to the paper so that it will fit, and so on. Okay, so for this case, it's here. Sorry. Okay, so that's how you manipulate. Then after that one, you save. Okay, save your report so that you will have a copy. You can print that one later. Okay. Export or report export complete. Just click OK. Alright, so after exporting the report and saving the report, we'll go back to Staad. Okay, so again, we are in the post-processing mode. You can tell that it's a post-processing mode based on the tabs here, the windows here. So if you want to go back to the modeling mode, say you want to change a section, or you want to add a beam, or you want to add additional loading or delete a loading, and so on, you can switch to the modeling mode. Okay, so let's go to the mode. We're currently at the post-processing. We're going to go to modeling. Alright, so here's the modeling mode. So if you want to change something, let's say you want to change the section of these beams. Okay, so you can do so. You can edit that one. Then let's say 0.25 by 0.2, something like that. Then change. Yes. Okay, so since you have changed something in your model, then the results there previously is not anymore accurate. So you have to run analysis again. Okay, so after changing, let's say you change the properties, the supports, the loads, and so on, or you want to change the design parameters, you need to run analysis again. Okay, so click analyze, run analysis, the same method, run analysis. You have to save it because there are changes. Then there's a run analysis mode. So you want to go to the post-processing mode again to check the results. But right now, we'll not go to the post-processing mode. We'll try to view the output file.